In our previous class, we discussed about hydrocarbons. Hydrocarbons are the carbon compounds which contains carbon and hydrogen. We studied that carbon forms number of compounds. So it is very difficult to give names for each carbon compounds. In earlier time, carbon compounds were known by their popular name, which mainly originated from source of its compounds. These names are originated from source of these compounds. But as the number increasing, it is very difficult to give names for each compounds and remember them with their properties. So scientists were thinking about giving a name for each carbon compounds for making some common rules. In 1892, International Union of Chemists met in Geneva and formed some rules and regulations to give a name for its carbon compounds. Later, it is named as International Union of Pure and Applied Chemistry, and this nomenclature, the technique of the rules of giving name to carbon compounds, is known as IUPAC nomenclature. Today we are going to discuss about the IUPAC nomenclature of alkanes. Alkanes means saturated hydrocarbons. We already studied about that. For giving name, we should know about word root of each carbon compounds. Word root is the first part of name, which indicates the number of carbon atoms contained in that carbon chain. For carbon compound which contains one carbon atom, the word root is meth, METH. For 2, it is ETH. For 3, it is prop, PROP. For 4, it is but. For 5, it is pent, hex, hept, oct, etc. We may familiar with some of these terms, pent, hex, oct, etc. We use pentagon, hexagon, octagon or octopus, etc. etc. So we are familiar with some of this. This word root indicates the number of carbon compounds in each carbon chain. So for giving name, first we want to know about the number of carbon atoms in that chain. So by starting this number of atoms, carbon atoms, we give ANE for alkanes. So a carbon compound which contains 5 carbon atoms, its name is pentane. Its name starts with the word root PENT, pent, and end with ANE, pentane. Another example, CH4. Its word root is meth plus ANE. So its name is methane. C3H8. Its word root is prop and add with ANE. So its name is propane, etc. etc. This is a way of giving name. For branched chain alkanes, you can see the example here. It's a carbon compounds which contains 6 carbon atoms. So we can give its name as hexane, but it has an alkyl group attached to this. 2 carbon atom attached to the third carbon atom. So it's an hexane derivative. Hexane derivative. This substituent alkyl group are identified and named. The alkyl groups are named by replacing ANE suffix of the alkane with YL. So alkyl. It is known as alkyl group. So If it contains only one carbon atom, it's methyl. If two, it is ethyl. If three, it is propyl, etc. etc. So the location of the substituent alkyl group on the main chain is specified by counting its number from end to the carbon chain, which gives its lowest possible number. So in our previous example, this compound is known as 3-ethyl hexane. 3-ethyl hexane, because the attached group contains two carbon atoms. So it is ethyl. It is attached to the third carbon atom. So it is known as 3-ethyl. The main chain is 6. So it is 3-ethyl hexane. I think you are clear about this. If two carbon atom is attached, we give name by their order of alphabetical order. So this compound is known as 3-ethyl 3-methyl hexane. Compound is hexane. An ethyl group and methyl group is attached to the third carbon atom. So it is known as 3-ethyl 3-methyl hexane. This we give by the order of their alphabetical order. If it contains two same group, just like here we give 2, 2 dimethyl butyl. Di, tri, tetra, we give like that. This is the important rules regarding the nomenclature of alkanes. Now we are going to discuss about the unsaturated hydrocarbons. That means alkenes and alkynes. The carbon compounds which contains double bond is known as alkenes. Alkene, A-N-E-N-E. In previous time, we use A-N-E. For single bond, it is A-N-E. For double bond, it is E-N-E. If a carbon atom contains only one double bond, then its name is changed as alkene. For ethane, it is changed as ethene. If it contains at least one triple bond, its name changes to alkynes, Y-N-E. So for single bond, it is A-N-E. For double bond, it is E-N-E. For triple bond, it is Y-N-E. I think you are clear with this. A-N-E, E-N-E, and Y-N-E. Now we can discuss about alkenes in detail. The simplest alkene is ethene because methane contains only one carbon atom. It has no way to make double bonds. So the carbon compounds which can make double bond start with ethane. So ethane makes, in ethane the carbon makes double bond. It changes its name as ethene. For ethane, the chemical formula is C2H6, but ethene, the chemical formula is C2H4. Two hydrogen atom is removed by adding double bond to carbon. This carbon has valency of 4. Two valencies shared with this carbon atom and one with each these hydrogen atoms. So it fulfills its tetravalency by making double bonds. Similar to alkanes, alkenes also forms homologous series of compounds which differ from a unit of CH2. The general formula for alkene is CnH2n. CnH2n. Ethene, propene, butene, pentene, etc. etc. They are differ by a unit of CH2. General formula is CnH2n. In the case of alkanes, the general formula is CnH2n plus 2. IUPAC name of alkane can be given as word root plus ENE. That means ethene, for example. Butene, pentene, hexene, etc. We can indicate the double bonds by number. For example, 1 butene, because uh, uh, the double bond is attached to the first carbon atom with the second carbon atom. If it is a double bond is second to third, it is 2 butene. If double bond is third to fourth, it is 3 butene, etc. etc. Then alkynes. Alkynes are carbon compounds which contains at least one triple bond with carbon and carbon. It is known as alkynes because we add YNE as suffix. For carbon compound which contains two carbon atoms, making a triple bond, it is known as ethane. For alkane, it is ethane, ETHANE. For alkenes, it is ethene. For alkynes, it is ethane, YNE. Ethane, propane, butane, pentane, etc. etc. It also forms homologous series different CH2. The general formula for alkanes is CnH2n minus 2. For giving IUPAC name, we give word root plus YNE. C2H2 is known as ethane. So you may understand about the difference between these compounds. For ethane, it is C2H6. For alkene, ethene, it is C2H4. For alkyne, it is C2H2. So the number of hydrogen atom is reduced. Then the bond is increased with the carbon atom. For making double bond, it removes two hydrogen atoms, etc. etc. In similar to alkanes, we give 1 butane or 3 butane, etc. for giving the for indicating the number of position of triple bonds. This is the way of giving names for alkane, alkene, and alkyne. For remembering homologous series in alkane, alkene, and alkyne, it is very simple. The general formula is very simple. We know the general formula for alkane is CnH2n plus 2. For it becomes alkenes, we can remove this 2. So it is changed as CnH2n. For alkanes, we want to remove 2 hydrogen atom also. So it is changed as 2NH2n minus 2. So it is very easy to remember all this. And also the double bond, triple bond is indicated by its number. 2 butane, 1 butane, okay, etc. etc. So it is very easy to remember all this name. In our next class, we are going to discuss about the functional derivative of hydrocarbons. Functional derivatives helps hydrocarbons to change their properties and making different compounds. We can discuss about that in our next class.